All right. Welcome everybody to another live stream repair. We've got a bunch of HomePods in today, and somebody's already bothering me. Let's see. Nope, don't have time for that right now, sorry. So we've got 3 HomePods in for repair today. Our first one comes from Brian, and we've got no power here. And all right. So they actually sent in just the board. So let's get that opened up really quick. There we go. So they sent this in from Australia. So, and they were comfortable with taking their own HomePod apart, so I had them send just the amp and logic board in to save a little bit on shipping costs. And I don't think we were able to diagnose whether it was the amp and or the logic board at the time, so I had them just send both in. More than likely, we've just got a shorted diode on the amp board, but we'll take a look and get anything we find fixed up here. So, we've got our amp and our logic board here. Let's go right on ahead and get our multimeter. We're going to set that into continuity test mode. And let's check to see our diode. Let's go ahead and pull up the close-up cam. Okay, that's not behaving, of course. Alright, my close-up cam decided today was not going to be the day for it to work, so we're just going to have to bear with the overhead cam. Let's check and see if our diode here is shorted. And indeed, we do have a short on our diode. So we'll go ahead and get that replaced really quick. Alright, got the old one off without a problem. Let's warm up our iron. grab ourselves a new diode. And we'll tin this up before we put it on the board. Just some flux. And some fresh solder. Okay, there we go. Let's get that heated into place. Alright, let's just touch those pads up real quick. Alright, that's definitely not going anywhere. Okay. Do I hope that it will someday be something other than this diode? You know, I don't mind that most of them are usually the diode because it's a pretty simple, easy, relatively safe repair. There are on occasion ones that come in for no power that aren't this diode. Sometimes, very, very rarely, it's a shorted capacitor on the logic board or a blown fuse on the power supply. But those I've only had one logic board come in for that repair, and I've only had 2 power supplies come in for that repair. Both power supplies were from the same guy. His building must have some pretty whack power because both of them had blown power supply fuses, not at the same time, at two different times, like a few weeks apart. So that was pretty interesting. But I wouldn't say that I generally hope that there's something other than the diode problem coming in for no power repair. But it does make things a little interesting, when I get something that I haven't figured out yet. The short on the logic board was interesting because I had done a lot of no power repairs based on the diode, and I had never encountered a short on the logic board yet. So that was really interesting to find all by myself. And once I found the first logic board short, I had another logic board that came in for mail-in repair for a short on a different location on the logic board. So that was also a fun challenge to work through. But it's nice to have the usual same thing coming in, as far as knowing that I'm going to be able to get it fixed for the person sending it in. For my own personal curiosity, I do hope that if I, when I buy ones, if I buy broken ones, that are described as no power, in those cases I do hope that I find something a little different than the usual shorted diode. So we're gonna throw a power supply on this board now that we've replaced the power diode on here. Check that it of course now powers on, and that their logic board works too. And we'll also get a chance to see if there's any DC offset on here before we move on to the next repair. So I've got a logic board cable right here. Let's go ahead and set that to the side and turn that off. Don't need that going anymore, hopefully. The idea here is well, actually I don't know, I'm just rambling, mindless rambling. But we are going to grab ourselves a display here. And find out how much DC, if anything, this has. I'm sure their logic board and their everything else works, and it's just this diode. But we had them send the logic board in anyways, just because it's coming from Australia, from so far away. We wanted to be sure. Gonna hook our meter up to the subwoofer. Watch the DC voltage on that while we plug this into power. And alright, good news, it's powering on now, so our no power repair worked. It was just that shorted diode, the usual. Their logic board is working. That's also good. And I've just got my own test display on here just to interact with this, so we can check for DC offset after it boots. Alright, it's booted. Let's wake it up. Alright, so we've got base, and we've got pretty much non-existent DC offset here, it appears. Yeah, so I'm on the 200 millivolts DC scale on my multimeter, and we're registering less than 1 millivolt, so that's a really good result. Looks like all we had to fix on this one is just that shorted diode. Let's unplug that from power, set their parts to the side, and we'll break out our second pod for repairs today. Okay, we got their stuff put away. Next up for repair is from Stefan, or however you would like that to be pronounced. That's how my middle name is Stefan, and that's how it's pronounced for me, at least. For this one, we've got popping and farting. So not the usual no power here. Oh boy. This one comes to us from Germany. So our first repair from Australia, and now here from Germany. Pretty cool. Where is my knife? Oh no, I'll just use this. Oh, here it is. Let me just get this open off camera so we don't reveal a bunch of personal info on stream. All right. Oh, by the way, these boxes, these original boxes that the HomePods shipped in, are wonderful for, of course, shipping your HomePods safely without damaging them. Not just the white box. It's important that if you just use this white box, which by itself is pretty good, but you're going to want to put the white box in another box. But they do really good for protecting these in transit. All right. Let's set this down and connect our power up. And let's just check that it powers on. We're expecting it to power on, but it should have a pretty healthy pop. All right, good. So it's powering up. We're booted up now. Let's listen as we wake it up. Ooh.
I'm having trouble connecting to... I'm having trouble.
Yeah, that's a really loud pop. All right. And I bet you when we unplug it from power, it'll be a pretty gnarly pop again there. Ooh. All right. Let's get this one torn down so we can test for DC offset, which is the source of that popping and farting. If you want to know more about DC offset, what it is, and how it affects these HomePods, I've got a little bit of information on my website at nixfix.com. If you go down to the common issues, scroll down a little bit until you get to the farting and popping section where it's labeled DC offset, and I've got a bunch of info there. The parts that you would need to fix this problem and ways to diagnose and repair that, as well as a link to a specific video on these repairs. So let's get this one cracked open. And what we'll want to do is get access to the insides so we can, much like what we did for the testing after we fixed the no power on that last board that we just had, we want to see how much DC is present across that subwoofer. Just to make sure that that's the source of our popping. More likely than not, it will be. But it's always interesting to see exactly how much there is before we go in and just replace those caps. Alright, we got all the screws taken out for the top display. Let's get a pry tool under there. And we're going to use the metal tool to give us room to wiggle the plastic one underneath. And then we can work that around the perimeter of the display and separate that from the adhesive underneath. And once we've gotten that free, we can unlock it, move that to the side. We'll go ahead and fix up the adhesive for our display here, just so we don't have as much work to do when we go to put this back together. And I'm sure our hands will be much sweatier by then, so better to get this knocked out now. Doesn't need to be perfect, just get a decent amount of coverage for when you go to put this display back in place. Okay, let's get these plastic frame pieces out. Alright, we got the frame out, so we can now get this logic board out of the way. Then we can get ourselves something to set this HomePod onto. So we can pull the mesh down. Also, let's get this logic cable detached from the basket right here. We don't want that getting ripped up while we pry this basket off. Cool. And we'll get these screws around the top basket here exposed so we can get those taken out. Awesome. Let's get those screws out now. Alright, we got all those screws around the basket taken out. We can commence the pry. Gonna wedge our screwdriver in between the basket and the woofer screws here. And just feeling the woofer as I push it in, it feels like it's in good condition, so we're gonna wanna pry against the screws and not against the woofer itself, so that way we can keep that woofer looking nice. Ultimately, it doesn't really matter too much because it'll all get covered up when you put it back together, but just in case the next person down the line wants to reuse the speaker for whatever reason, and you don't want to put a bunch of scratch marks in the woofer around its basket, you can always pry up against its screws instead of the frame. I'll show you what that looks like here after we get this off. That actually feels loose enough to pry off by hand now. Too easy. Let's get this put back on. And let's take out the subwoofer now. It's all pretty much smooth sailing from here. Just peek the condition of the voice coil really quick. Looks all right, feels all right, and smells all right. Let's get this out of the way here. Unscrew these plastic rings. Very nice. Very nice. Let's get the power supply disconnected, at least part way. We'll unscrew that and then pull it out. Alright, power supply is out. Let's disconnect this logic board cable. And finally take out the 14 screws for the amp. Cool. Screws have been removed. Let's pull this out and make ourselves some room. So, if we zoom in as much as we can here without losing too much quality, let's just do a quick visual inspection around the board. Our resistor right here looks to be in good condition. Usually this gets blown out when you've got too much DC offset. But luckily, it looks like they caught this and sent it in for repair in time before there was any real damage done. So all we should need to replace are the 4 filtering capacitors right here on the back. What date code do we have on our power diode? I'm curious. 1748K. So it is powering on, but it has the devil's date code on there. So we're going to replace that diode while we've got this, because we don't want this failing in a month or two from now for not powering on anymore. The date code on that diode, 1748K, seems to be the most common one to fail, so we're just going to want to avoid that, nip it in the bud. Before we replace anything though, let's put a power supply on this and connect a few other parts up to it so we can do a quick check for how much DC we've got exactly. I'm just curious. I'm also apparently can't even screw a screw in. Apparently can't talk either. There we go. And let's grab our logic cable. Get that locked into place. We'll grab one of our logic boards that have already been set up. We will plug a woofer into this. That's connected to our multimeter. Power that up. Then last but not least, we gotta put some power to it. So let's get that connected and plug it all up. So it's booting up now. We're gonna watch our meter up here in the top right for how much DC appears after it finishes booting and we wake it up. Typically, you don't want to see more than around 50 millivolts DC across your subwoofer after you wake this up. You don't want to, and what I mean by waking it up is go ahead and unplug it from power for 10 to 15 seconds. Wait to be sure that it's completely powered off, and then plug it in. Tap the top of it as soon as you plug it in to, bring up that, you see that white boot animation. That white spinning circle as it's booting up. Go ahead and tap the top of it to show that boot animation, so that way you know when it finishes booting, when it's ready for you to wake it up. And just to wake it up, just tap and hold the top of it for to wake up Siri. Don't pay attention to the reading on the meter while Siri is talking, or it makes while it's making any noise. Wait a second or two, and then observe the DC voltage on the meter across the woofer. And then that's what I mean by waking it up. So when you want to test for DC offset, unplug it from power for 10 to 15 seconds, plug it in, tap the top of it, and wait for it to finish booting. Don't reset it, just tap the top of it to observe how long it's taking for it to boot, so you know when you can stop waiting. Trigger Siri or something and observe your DC offset. I'm gonna have to bump up the scale. It's at 750 millivolts. Already 800. Already 1 volt. 1.2 volts. We're going to have to put that onto the 20 volt scale here, because it seems to be jumping past my 2 volt scale. That's kind of scary. Let's see what we've got. Let's see if we play any music, if it wow, that's volts. That's flat out volts. That's scary. All right, we're unplugging this. That is really scary. That was like... Huh. Wow. What was that, 10, 13 volts? Oh, and of course the multimeter camera's not working. That's dumb. Let's try something. Okay. I'm going to plug that in again really quick for you. And we'll watch again how much DC appears on that meter. I'm going to go grab a beer. Okay. Is our meter... Cool, our meter's live. Our pod is booted. Let's wake it up and observe that DC offset again. Mind you, we're on the 20 volt DC scale now. We're no longer on the 200 millivolt scale or the 2 volt scale. We're on 20 volts DC now. So let's wake this up and observe. I'm going to crack open my awesome tasting beer. And within a matter of 30 seconds, we're already at 1 volt. One 1.1. 1.2.
You'll need to update your Apple Music chipset to allow me to do this for you.
1.3. I wonder if my meter was just acting up because this is a pretty solid... These are some pretty solid results as far as the DC offset that, you know, before it was fluctuating pretty wildly between like 1 volt and 10 volts. Oh, see that? Whoa! There's no way that's... There's almost... I wonder what that means. Because there's no way it's putting 20 volts to the speaker. You would see the speaker. You'd see it pretty much blow up. With that much power, can it also hurt other components? Absolutely. The amp I see, for example, is only rated for a certain amount of DC offset going into it before it amplifies that signal and sends it to the subwoofer. So let's say you've got 5 millivolts of DC offset from the DAC going into the amp. That could be amplified to 10 to 20 times as much to unsafe levels. Actually, no, hold on. Let me pull up the... I think there's a specific level that the amp is rated for. Right. Right, okay, so the amp I see is rated for up to 18 millivolts, which amplifies to around 200 millivolts. So already you're talking about possibly frying the amp, the woofer, probably this resistor right here. Wow, we're already at 2 volts. See that? When I blow on it to cool it down, our DC offset decreases too. So if the, let's go ahead and unplug, or let me grab a different amp. I know I have another amp board floating around here somewhere. Okay, so let's talk about DC offset really quick. If we look on the back here, the subwoofer is driven by a different dedicated amplifier than the tweeters. So first of all, that's why you only hear the popping coming from the subwoofer, not the tweeters, because the popping is coming from the amplification circuit specifically for the subwoofer, and that is located right here on the back of the amp. Now, DC offset is basically just an amount of DC that is present across your subwoofer. Audio signals are AC, not DC. So when you have an AC signal, the subwoofer is moving, but with a DC signal, you're telling the speaker to sit in one direction or the other and sit there instead of alternating like an AC signal. It's a direct current, it's a DC signal, and it holds the woofer in one place or the other, which overheats the coil and can put additional wear on the other components. So if we look, let's take a look at another woofer here that we've got that has been killed by DC offset. If you look, the middle almost looks like it's got a darker spot than the rest of this dust cap. That's because what happens is that DC will push and hold the speaker in one position, like say like that or like that, and instead of moving it back and forth continuously with an AC signal, it's the DC that holds it in a certain position, prevents the voice coil from moving and naturally cooling itself, and that's how your woofer will overheat. The source of DC offset, it's normal and it's pretty much expected and almost inevitable for all audio amplifier circuits to have some amount of DC offset. What matters is how much DC offset there is. Most people say that anywhere around 50 millivolts or less DC is not really hearable. You can't hear it, and it's not going to cause any harm to anything. That's 50 millivolts at the speaker. Now, if we're looking at the amplifier circuit, what happens is the digital audio signal comes from the logic board through the ribbon cable and goes into the amp board. And that digital audio signal first goes through the DAC right here. And then from the DAC takes that digital audio signal and converts it to an analog AC audio signal. But it's pretty weak. It's not loud, and it's definitely not loud enough to drive a subwoofer yet. So what it does is it then goes through an amplifier IC dedicated for the subwoofer, which amplifies the audio signal, applies a gain, and sends that to the woofer. The DC offset inherently comes, I think, as part of the circuit for the DAC. Not that replacing the DAC is going to fix it. Like I said, DC offset is inevitable for every audio amplifier circuit. That's what these capacitors right here are supposed to remove. So these 4 capacitors are supposed to, These 4 capacitors are supposed to filter that DC offset out. We were talking for too long and the HomePod went into standby mode. So that's why our DC offset went to 0 volts. And I just woke it back up again, so our DC offset's now rising again. Anyways, these 4 caps are supposed to remove that DC offset. Caps go bad. Electronics just go bad eventually. They don't just work perfectly forever. So any one of these 4 can start going bad and throw that DC offset out of control, like we're seeing here. And that DC offset, before it gets to the amplifier, can be very little. It could be 5, 10, 15 millivolts right here. And then when that gets sent to the amplifier is going to gain that by like 10 times. It's going to amplify that DC. It's an amplifier, so it doesn't care if it's an AC or DC signal. It's going to amplify what it's fed. So if you're giving it an AC audio signal with a DC bias, this amp is just going to amplify all of that. So what may be 18 millivolts of DC coming from your DAC circuit gets amplified into upwards of 200 millivolts that gets sent to your subwoofer. So what you need is to replace these 4 caps in order to restore that, in order to remove so much of that DC offset again before the audio signal is amplified and sent to the woofer. Too much, or should I say, these capacitors failing to do their job so much that they allow so much DC to be passed into the amplifier IC. This amp IC is only rated for upwards of 18 millivolts. More than that and it's going to start triggering restarts, farts, and it could potentially start burning components out. So hopefully that 10-15 minutes of rambling was made enough sense to you. Let's go ahead and turn our meter back on. We're already at 2.5 volts. Watch the subwoofer here. I'm just feeling how warm it is. Doesn't actually feel too warm right now. Yeah, no, it actually does. If I put my thumb right in the middle of the dust cap, it definitely feels warm. Interesting. Watch this speaker move as I unplug this from power. That is DC being applied to your speaker. That is why you don't want DC on your speaker. DC bad, AC good. Well, I mean, don't go plugging your speaker into your wall outlet either, but you know what I mean. I think we've rambled enough about this, so let's go on ahead and take these test parts off and fix this DC offset. So ideally what we're looking for after we fix this, after we replace those 4 filtering capacitors, we should see no more than 50 millivolts on the speaker itself, which would be about 4 to 5 millivolts of DC before the amplifier, But we always measure at the subwoofer, so that's going to be no more than about 50. Okay. So we are looking at let's see, does that look too crappy or is that all right? I mean, I'd be surprised if anybody's still watching after me rambling for that long at this point, but okay, so let's go on ahead and replace these 4 caps, and then we'll go ahead, flip it around, and replace that power diode just to stop or prevent that no power issue. Okay, while we got those 4 caps off, let's go ahead and pull that diode off too. Awesome. Let's get our new parts out. So we're gonna need a new diode and a couple of new caps. Okay, then we're gonna grab our iron and tin all this stuff up before we put our new components on. Ooh, have fun on your way to Hawaii, or in Hawaii, I should say. I've only been to Hawaii once, but I absolutely loved it. Probably second favorite place I've ever been, coming short to Japan. Just short though. Japan is just really cool. Okay. Let's put those new caps on. Then we'll flip this around and put a new diode on. Then we'll throw this back together on the bench, verify that we've got no more DC offset, or at least no more than 50 millivolts. Then we'll throw this back together for a sound test, move on to our third repair. There we go. Check and make sure those are all lined up nice, not shorting out on each other. And we'll flip this back around. Get that new diode in. Beautiful. Oh yeah, what's up, Tony? No, I read your email. I haven't gotten a chance to reply just yet. Oh no, I did. I think I did actually. I'm starting to mix up all the emails. I'm starting to get like anywhere from 10 to 20 emails a day from people out for all sorts of HomePod stuff. Half of them repairs, half of them questions about fixing their own. It's getting wild. But the good news is I've got a couple of people who've reached out to me now who have let me know that they are also doing repairs. We've got one person in the UK, and I think they're in the UK. I can't. And then we've got one other person who's in, I believe, France. Excuse me. Goodness. So I don't care about the competition as long as people have options. I mean, if I cared about competition, I shouldn't be making tutorials on how to fix it yourself. But you could write a book on how to make $1 million, and it would be a guaranteed set of steps on how to make $1 million, and people will still pay you to do it for them instead of them just doing it themselves and agreeing for you to take a cut from it. That's what I think. So I could put all the information out there to fix your own pod, but at the end of the day, people will still want or need to have theirs fixed for them. Okay, so we're just throwing this back together on the bench. We want to check and see if and how much DC is now on the woofer. We've replaced those filtering capacitors that are supposed to remove that offset. And we are now plugging this all into power to confirm. Alright, it's booted up. Let's wake it up and give it a test. Oh, we're on the 20 volt scale. Let's go ahead and bump that all the way back down to the DC millivolts. And we've got a spectacular result of, looks like it's probably going to hover around 2-3 millivolts. We're going to go ahead and just sit for another minute here. But yeah, so we are on, oops. We are on DC millivolts. So we're on the 200 millivolt scale right now, and we've got 5 millivolts. Far below the maximum acceptable level of 50. So this is a really good result. And if we unplug it, we shouldn't have much more than a very, very, very light pop, as opposed to the table shaking woofer roasting pop that we had before. Let's find out. Yeah, that is wonderful. That is wonderful. So let's throw this all back together properly in their pod. And we are going to, just to be sure, after I get this all put back together, I am going to throw the speaker on like a 1 or 2 hour test, just to make sure that we don't see any more farting. But it looks like we've got all of the issues repaired. We've got the DC offset corrected. We replaced those filtering capacitors. And we noticed the power diode had a date code of 1748K. Despite it still working, we went ahead and preemptively replaced that Schottky barrier diode that commonly causes no power issues. Again, even though this powered on without a problem, we went ahead and replaced that because we're already in here and we've seen so many other diodes with date code 1748 or 1746K that have failed and caused that. no power issue. So we just want to, you know, if it's easy for us to prevent, we're going to prevent it. And we saw it, we're going to prevent it. If it was any, if the diode had a date code older than 1748K, I would probably still go ahead and replace it. Just because I can't be 100% certain that the diodes are failing because of a bad batch in the 1748K date code, date range ish. That's the primary. That's my first guess though. That's my best guess is there was just a bad batch of diodes that caused the no power problems. But there have been a handful, very few rare exceptions, but there have been a few that haven't had that date code. And there have been a few with that date code that don't have that problem. But the overwhelming majority of no power repairs have a shorted diode with date code 1748K. So if you see it, replace it. Heck, if you're already in there, you might as well just, and you're not repairing a no power issue, you might as well just replace that diode anyways. Because I'm telling you, it sucks sometimes having to put this thing back together and then take it back apart because you missed something, or a month later it comes back to because it fails due to some other common issue that you could have prevented. I noticed that some repair YouTubers, well, okay, so I'll say this. Because I specialize pretty much in repairing these HomePods, I can afford to take the time to replace all of the components that commonly fail, even if they haven't failed yet. You know, if you send yours in for no power, I'm going to diagnose DC offset and do the repairs for DC offset while you've got it here. And if you send it in for DC offset, I'm going to do the same thing as I would with no power repairs and still replace that diode. Just because I know how common these issues are. I know what to replace, I know what parts to replace them with, and I can get the parts relatively cheap. And the time it takes to replace those components that commonly fail far outweighs, it's far better and far more preferable than the time it would take for somebody to ship their pod in to get one specific issue fixed and then have to send it back in a month later for a different common issue, the same pod. Like, just get it all fixed at once. It only takes another minute or two at most if you're proficient at replacing components on a board. At this point, I am really just rambling because I feel like, I don't know, I feel like talking is better than silence. But I've got plenty of live streams where I'm completely silent and you just got straight up HomePod repair ASMR. And I've got live stream repairs where I've got non-stop chatterhead. So you can stick around for whatever suits your fancy, and if it doesn't, you can leave. I've actually not had any complaints though. I've only had one criticism, and it was constructive. They were just letting me know that the audio in all of my streams early on it was really quiet. And it turns out I had the gain turned like all the way down in my microphone settings in OBS. I don't know how that happened, but I had done probably 10 or 15 live stream repairs with my audio like that, and nobody said anything. Everybody kept praising me and saying, cool repairs, cool live streams, like, good job, this is really cool. But it took one guy that, had the balls to say, like, yo, this is really cool, but I just want you to know, like, I think your audio is too quiet in your live streams. So I went back and I listened to them, and I realized, like, I never noticed because I had my my desktop audio, like, that goes through my audio amplifier to my speakers. I had that cranked up so much that I never noticed that my audio was ever too quiet in the first place. So after I got that fixed, yeah, and I guess I should have realized that when I'm watching back my own live streams on my phone, that I shouldn't have to have the volume up all the way to hear myself talking. I should only need the volume on my phone up at max, depending on your, environment, of course, but if you're in a silent environment, at max it should only need to take, like, at most a quarter of the volume or an eighth of the volume in order to hear somebody legibly talk. So I really appreciate that guy for taking the time and saying that, because I might still be all these months later, all these months, I might still have been broadcasting with really quiet audio and not been any wiser to it. I think I had one guy say that my microscope is crap. I don't have a microscope, so that wasn't a valid criticism. But I know what they meant. I know what you mean. I just, for the volume of, okay, well, I can't say that soon, but for now at least, for the amount of HomePods, honestly, that come through, yeah, it might seem like a lot, but I don't know if I can justify spending thousands of dollars per each specialized tool for things. So, people are like, oh, get this soldering iron, get this microscope, get this thing and that thing and the other thing, and it's like all these tools each are easily like hundreds or thousands of dollars a piece. I don't have the volume in the capital and all that. I'm just working out of my house. I don't know if this will ever grow into a thing where I can sustain a business off of it. So for now and for any time in the near future at least, the quality of the tools that I use and the cameras and all of this pretty much solely depends on how much I can actually make off of all of this. And if you haven't noticed, the prices that I'm charging for this are almost what people keep telling me that I need to charge more, and I've already bumped my prices up multiple times, and people still keep telling me that I need to charge more, and it doesn't. I'm trying to keep the pricing at a reasonable balance between, like, I want to make it worth it for you to consider sending it in for repair, as opposed to looking at Apple and just paying them the $280+ to just get it replaced outright with another unit that's just going to have the same problems a few months from now, but that's beside the point. I want to make it seem like a viable, like, alternative to just going and buying another one. And if I want to do that, I can't price my repairs for anything more than around, probably $80 to $120 max. before shipping. Yeah, I don't know. I could charge more. I'd probably get less volume. That's not what I'm interested in. I'm interested in, at least while I can, helping people. Making it worth my time. I'm not, without going broke, but without, driving myself crazy either. I want to make it worth my time, but I also want to make it worth other people's time too. Yeah, the rumor mill's running strong with the new HomePods. The rumors recently have shifted from release end of this year to announcement like closer to like next year. I think the new HomePod hardware will be announced at the end of this year, along with the new iPhones, and I believe the release of iOS 16. It would make sense. New OS, new HomePod hardware. iOS 16 is supposed to be this huge leap in home automation between Matter and HomeKit's upgrades. And it just makes sense to have the new hardware launch at the same time to support all of that. Or at least announce that the hardware will be launching soon. They'll probably either launch and announce the new HomePod at the end of this year, or announce the new HomePod hardware and when it will be released, like probably next year. But at the end of this year, they'll probably announce it. They'll say something. I'm really hoping, and I'm really hoping that the parts are compatible, at least somewhat. Alright, we got a little bit of interference from the adhesive here. What we're going to do is just pull this out a little bit. We're going to go ahead and cut off the bits of adhesive that are preventing this top basket from sitting flush. We don't need to take all of it out, but enough that this sits flush without any force. There we go. Then we can screw that down. No, I don't think anybody's been able to fix the blinking volume button still. It's not going to change until somebody else hacks into them, or Apple releases firmware to allow us to restore them. Blinking volume buttons are never going to be repairable until I've given up on the blinking volume buttons. Sad to say, but until somebody else is able to help with the software side, I can get the hardware. I can get the HomePod to connect with a computer. I can't figure out the software. And I don't know if I'll ever be able to. I don't know if I'll ever have the time to. That might change one day, but it's not anytime soon. So at this point, I hate to say it, but I've pretty much given up on the blinking volume buttons. Apple needs to give us access to download and restore the software to these, because you can already, like, there is a way to connect these to your computer via USB. It's currently possible, but Finder shows that the HomePod is connected. Finder gives you a button to click restore. The computer reaches out to Apple's servers to pull the firmware for HomePods to restore the HomePod, and then it doesn't have access. It just says it couldn't find any firmware, it couldn't find any available software to restore to this HomePod. This is absolutely arbitrary. And if there's a specific hardware failure behind it that's causing it, we need a way to know. We can't just have this generic error message that's vague and all-encompassing, where it could legitimately be a software issue. You know, it's already been confirmed 100% that if you unplug the power from your HomePod during a software update, more likely than not, you are going to brick it and end up with flashing volume buttons. So we already know there are simple, user-created, irreparable ways of getting these into the flashing volume button state. We also know that there are certain hardware failures that can cause the blinking volume buttons. The problem, again, is there's no way to differentiate that between not having any firmware to restore to these and not having any software really to see any error codes when you do try to restore them. Finder works well for clicking restore. Like, Finder recognizes a HomePod is connected to the Mac. If you remove the rubber foot on the bottom, you'll see these pins. 4 of these pins are for USB, and you can just straight up solder a USB cable to this and then plug that into your computer, and then Finder recognizes a HomePod and you can click restore. There's a button for restoring. It works. You can click restore, but it reaches out to Apple servers and it can't find shit. And then Apple tells you to go fuck yourself. Excuse me, language. Apple tells you to buy another one. I'll say that. Alright, we gotta get this fixed so we can move on to the next one. The third and final repair. I could sit here and ramble all day about the things wrong with these HomePods and Apple. Doesn't change how much I love these HomePods and Apple, but it also doesn't change how much I hate these HomePods and Apple. It is very much a love-hate relationship. Much more love for the HomePods and much more hate for Apple, but because, you know, as Louis Rossmann said, the HomePod didn't ask to be a HomePod. It was just a HomePod. It just is. It just was, and it is. It didn't ask to be it. Apple made it. And Apple made it this way. But why? And it's even more frustrating that they spend over $200 per unit to manufacture. It costs them over $200 per unit to manufacture. I've said that twice. Don't make me say it 3 times. And they still just they made silly mistakes, and then they don't own up to them. So frustrating. And good luck ever getting them to own up to it too. now that they discontinued them. I mean, it's been a while since they've discontinued them at this point. And good luck now that there's rumors of a new one being launched. Like, people are even caring even less about the problems with the old ones. They're just hoping they can sweep all of this under the rug. And they can't keep getting away with this. Even when shift clicking on restore, it doesn't open the menu. So yeah, you can shift click to restore, and it brings up the menu to let you pick a custom file to restore with. But what file are you going to restore with? You don't have it. Like that's the problem. There are no firmware files publicly available for the HomePods. Sure, there's the OTAs that you can download. There's the builds from the minis that you can download. But those aren't compatible with the original HomePod. And the OTAs are not restorable. So the OTAs are only good for, again, over-the-air updates. That's what OTA stands for, over-the-air. OTAs are what you can download currently from ipsw.me if you manage to find the HomePod model on ipsw.me. But those OTAs are only captured from working HomePods, and those OTAs are just update packages. Those aren't full operating systems, so they're not good enough to restore with. And then your next question will probably be, can't you dump the firmware from another working one? And the answer is yes and no. Yes, you can, because these run the A8 CPU, the A8 SoC, system on a chip. That A8 is permanently vulnerable to checkmate exploits. That's I think that's a bootloader level. I could be wrong. Boot ROM, bootloader, something like that. It's a super low level, unpatchable vulnerability. That basically means you have full unprivileged access. Now, despite having that checkra vulnerability, and despite having tools that are currently capable of jailbreaking other A8 devices, the Apple HomePod specifically does show up as a slightly different device. So any of the current checkmate tools or jailbreak tools or firmware dumping tools that currently support dumping other A8 devices don't properly work with the HomePod. I've already tried it. So that's the no part of that answer. Yes, they can be. You can dump the firmware from these with checkmate, but you can't currently because none of the current tools actually properly support and recognize the HomePod, despite the hardware being part of the permanently vulnerable, despite being permanently vulnerable to the checkmate exploits. Goes back to, what I was saying earlier in the stream when I was answering your questions about blinking volume buttons. I've given up on it for now. I've gotten the hardware side. I can connect them via USB. but I don't have the software, and I don't know if I'll be able to figure it out. Someone smarter, and there's a lot of people out there smarter than me. I'm dumb as I'm real dumb. But someone smarter than me needs to take a look. I'll provide the hardware if you can figure out the software. Yeah, I was like, I've even been tagging I've even been tagging the frickin' Lapsus, like, hacker group and, like, all these different hacker groups on Twitter, trying to get one of them to, like, recognize how much Apple has slipped up on this, and just getting them to, like, please just leak me one HomePod IPSW, please. I don't care if it eventually becomes unsigned and I can't restore to them anymore. I just want to fix one. I just want to see it work once. I just want the proof of concept, at least. And then we've got the ammunition to... I'd imagine we'd have what we would need to basically take it to court and force Apple to let us do it. Like, have actual recourse for these bricked HomePods, and not just, well, you screwed yourself. Alright, we've got that all reassembled. Let's just do a sanity check. Plug it in, make sure, of course, that it powers on, that our volume buttons are lined up and evenly illuminated, and that our popping, if there is any, is quiet or unnoticeable. Popping is normal as long as it's, chill. Too much popping, too much salami. A little salami is okay. We've got power. Wait for it to boot up. We're booted up. Let's check for the pop.
I'm having trouble connecting to the...
I didn't even hear any popping. Amazing. And let's see if we can get the volume buttons up. There we go. And those are lit up nice and evenly. So we've got this second HomePod from Stefan all fixed up. we fixed that popping issue. We'll go ahead and do an extended sound test off stream for an hour or two just to make sure that it doesn't fart after some time. Based on the multimeter results that we saw while we were testing on the bench, I would expect this to fart within 5 to 10 minutes of music playback. Not that long. So we'll go ahead and disconnect this from power. Set it to the side. Actually, we won't quite yet. We are going to take a quick intermission here. We've been going for almost 2 hours, and I need to use the bathroom and get some water before we start on our third and final repair from Ben for no power. And that's the whole pod. So we've probably got another 45 minutes to an hour's worth of work left. But let's go ahead and take a quick break here, and we will be back in just a couple minutes with Ben's HomePod to fix their no power issue. All right, we are back. Let's get this second pod out of the way here. And let's go ahead and open up our third and final pod today from Ben. Let's get this updated here. And let's go right on into it. All right. There we go. All right. Here's our pod. And looks like their cable's a little dirty. We'll see if we can clean that up with some rubbing alcohol when we're all done here. But first, let's verify that we've in fact got no power here. Alright, so we've got the usual about 5 watts of power draw from the wall. Nothing from the pod. Pretty typical for a shorted diode. So let's tear this one apart and take a look at the insides. Let's go ahead and start by getting this display pried off, or actually I should say the top touch cover. This is purely just a cosmetic piece. It'll work just fine without it. There we go. Let's get the screws out for the display here. Get the display pried up. Let's get this up a little more. Didn't quite get in there enough. Oh no. This pry tool is not long for this world anymore. There we go. Okay, let's get this frame taken out. Put this on top of some tape here so we can pull that mesh down. There we go. Screws out. Oh, somebody said something in the comments about they also spent millions of years developing it. I think they said they were developing it for 5 years on their keynote in 2017. That sounds about right. Would be very happy if the logic board is compatible with the old one. So I don't think, so here's what I think. The logic board you won't probably be able to just put the logic board from a new HomePod into the original generation. You'd probably have to replace the logic board, the ribbon cable, and the amplifier and power supply inside with the new gen. But I would be surprised if they changed much anything else as far as the speakers and the physical design. But I do think that because they're going to use a new chipset, they're going to be using a new logic board that won't necessarily just plug and play into the older HomePods. You'll probably have to replace the cable and the amplifier that logic board connects to as well. But that is just pure guessing and speculation. We won't know until they actually announce these things. Codename B620. Wonder where B620 comes from. Alright, let's get this logic cable detached from the top basket before we pry this off. And we can now pry this off. Okay. That should be loose enough to pry by hand. There we go. Set that back down and all easy peasy from here. Cool. Subwoofer is unscrewed. We can pull this out. Let's just peek the condition of that real quick. Happy and healthy woofer. Let's move on. Cool. You can pull this power supply out now. The resistor on this power supply looks a little discolored. If I compare it with another one here. Actually, that looks pretty normal. Let's just measure it just to be sure. Uh, 0.7, and what does ours look like? 0.7. So they're both the same. So their power supply looks, for all intents and purposes, fine. So yeah, more than likely they've just got a shorted diode on this amp board here. Let's go on ahead and pull that out. Take a closer look. Just got only 14 screws on this amplifier board. Come on, Morty, it'll be nice and fun and easy. Quick and easy, in and out, 5 minutes. No more. Just 14 screws. I promise, no more. All right. We got the good stuff. Let's fix. So our diode is located right here. If we take a zoom on in, this will most likely be our culprit, like most no power repairs. We've got a date code 1746K on here. Let's do a quick check with our multimeter. No, don't. I don't know why the hot air gun's turning on. We've got our multimeter here in continuity test mode. And our diode here does in fact appear to be shorted. So let's go ahead and rip that diode off. Replace it with a new one. And then we should be able to power this board on. Old diode has been removed. Let's grab a new one. Let's get some flux and fresh solder on that new diode, and we'll install it on the board. Got that new diode positioned on the board. We're gonna resolder or reflow that into place, I should say.
Yeah.
Excuse me. Burn. 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 Wonderful.
Yeah.
Excuse me. Excuse me. Oh. You don't want to hold that in. That's not healthy. Like, sure, it may be a little offensive to some, but I'm not going to hold in a natural bodily function for the sake of not offending you. I apologize, but that's just the way that I am. Let's cool this down. Oh, we got some more chats. What do we got? Your voice got some DC offset. Yeah. I would be lying if I said that nobody's ever mistaken me for Dominique on the phone. It's not by choice, I'll tell you that. But I don't mind, and I don't care. I've had my fair of misgendering people on accident. Alright, we're just throwing this together on the test bench just to make sure that it powers on, that our no power repair worked. But we also want to check and make sure that there's no DC offset on here. If you haven't noticed by now, the theme of my repairs in general is don't just fix the problem it was sent in for, but check for everything and fix everything. So even though they sent this in for no power and they had no mention of popping or farting or any of that, we've already got it apart. We've already got it here. They already paid the money to ship it to us, and it only takes us an extra few minutes to throw everything together and check and repair for DC offset if there is any, even if they only sent this in for no power. And vice versa. If somebody were to send in one of these pods for the DC offset, the popping and farting issue, but it didn't have any no power issues, like obviously it powers on fine, it just pops, we would still, more likely than not, replace that diode that causes no power issues, because we just, I don't know. I was young. When I was young enough to still be pooping my pants, one thing that I do remember my mom telling me and sticking to me really, really hard was don't, do it right the first time so you're not going back and having to do it again. And how I interpret that is fix everything. Fix what you know can cause problems, especially if it only takes an extra minute to swap a diode that you know is going to probably fail in a few months. So let's get the logic connected to this. We'll get this assembled on the test bench and just check for obviously that it powers on and that we've got no DC offset to repair. Let's get all this stuff hooked up, and we're going to connect our meter to our woofer here. Okay. We get all that plugged in. Let's go ahead and power this on. And awesome. Our no power repair worked. It's booting up. So we'll wait for this to finish booting and check for DC offset. Alright, booted up. Let's check. And we've got 40 millivolts. And it's rising rather quickly. We're already at 50 millivolts. Yeah, and it continues to grow. So even though we only started at 40 millivolts, there's two reasons why I'm going to go ahead and replace, or why I'm going to go ahead and do the filtering capacitor replacement too. Two reasons. Even though this only started at 40 millivolts, it's growing, and it's growing rather quickly. And the second reason is we've already gone past 50 millivolts in the minute-ish that we've been plugged in and woken up. We're already at 70 millivolts. If this was less than 50 millivolts and it wasn't growing, I wouldn't care. It would be good. We would throw this back together and call it a day. We've got the no power issue fixed. Nothing else needs to be fixed. But the fact that this started at 40 millivolts and is growing rapidly and we're almost at 80 already, that to me warrants going ahead and replacing these capacitors that normally cause that DC offset issue. Because this is certainly an early sign of that happening. So let's get all these parts back off really quick. And my test bench power supply, if you've noticed, a lot of the times I'm testing with my power supply and not the customer's supply. And you'll know it's mine and not the customer's because I've got, where's my plastic pointing tool? We'll grab this one. You'll notice I've got do not sell written on my power supply that I use for testing on the bench. This is their power supply and this one's mine. And I like to use mine when I'm testing for DC offset because I've cut away the plastic on the power supply right here. So that way I don't have to keep taking the power supply off. So I don't have to take the power supply off in order to replace these caps. I like to take the power supply off because the heat will otherwise melt the plastic on the power supply here. So, you know, if it saves me a minute, then I'll modify a power supply specifically for being able to keep it on there when I needed to do common repairs. So let's get those taken off, and we will check what the DC offset behavior is after we replace these capacitors. So of course we need to first take them off. Just gonna heat these up and rip them off with the hot air. Easy peasy. Got all 4 caps taken off. let's put some flux on here, on the board, on those pads where those caps used to be. And we're going to freshen those pads up with some new solder. Of course, prepping them with flux right beforehand. But we're just going to hit these pads with some new solder really quick. Makes it way easier when we go and put the new capacitors on. And it'll give us that nice, beautiful factory look. And proper flow of solder when we put those new caps on. We don't want to just slap those new caps on there and you know, oh, they look like they're on there, so it'll work. Yeah, no. We want to make sure that we get nice, solid, quality lasting solder joints on these, so we don't have to cover the cost of having someone send their pod back in to fix our own mistakes or our own laziness. Do it the right way the first time. Okay. Let's put our new caps on here. Actually, I'm going to start from the back first. No reason in particular. I just want to see if this is any easier than starting from the closest one to me and working backwards. Looks like we bumped our other one a little bit. Easy fix. Just move that back. Let's clean up that excess flux off the board. I mean, it's not going to hurt anything if we leave it there, but if for whatever reason this one gets sent back into Apple, it's not like they would probably, I don't know if they would know, but I don't know. That might be an interesting thing to try. That might make for an interesting video idea. Fix a HomePod, send it into Apple for repair. Or better yet, assemble a dead power. Take a dead power supply, a bricked logic board, a blown amp board, and a shell that rattles with mesh that's banged up and a cracked top touch surface. Also with a display that doesn't have ambient brightness, or Let's throw all of those parts together into the single most biggest clusterfuck of a HomePod and send that into Apple for repair and see if they say anything about it. I'd be curious. I think I've got enough broken parts sitting around to throw something like that together and see what happens. I think this is cool enough for us to throw back together for a quick test on the bench. We've already fixed our no power and confirmed that. We were just checking to see if our DC offset is now under control. All right, we're booting up. Yeah, definitely. I'm definitely throwing in a logic board that has blinking volume buttons. There's no way in a million years, burning in hell for eternity, that I would ever send Apple a working logic board in a HomePod for repair. I would definitely be sending them a bricked logic board. Or if we want to get like super dick, we could send them a logic board that I've already picked all the parts that I want off of. then that would be interesting. I think I'm going to do that. Keep an eye out for that. Let's wake up this pod and see if we've got our DC offset under control. I didn't hear anything of a pop from that. And our DC offset is at a chill 3 millivolts and falling. So that's an excellent result. I think we're in the clear. Let's unplug that from power. And let's go ahead, throw this back together in the customer's shell, do a quick final check, and we will be done for the day. Of course, got to get all my test parts off of here. I wonder if they actually disassemble them and check, or later on use parts for refurbished ones. But I guess the refurbished storage of them is still from original assembly batch. There are 3 different model numbers for the original HomePod. There's the original manufacturer run model number. Then there's the model number for original manufacturer run, but set aside for specifically customer replacement and repairs. Those units are identical in every way, shape, or form to the original manufacturer run, but they just have a different model number indicating that they are a customer replacement unit. That's the only difference. And of course how they're packaged. They come in a white box, not a box with graphics. And then you've got a third type of model number. That model number indicates that it is a repaired or refurbished unit. And those ones are interesting. Those I think are interesting. Because they still have, as far as I can tell... Actually, hold on. Let me go and look... Let me go check really quick, because I took a survey. I posted a survey to the HomePod subreddit, and I asked everybody to submit their date of manufacture and model number and all that information. And I think I saw one of the manufacturing dates was wildly newer than any other HomePod I've seen. And I think that was associated with the one that had a refurbished and repaired model number. So the model number starting with M is the factory new. The model numbers starting hold on. So, model numbers starting with M are factory new. Model numbers starting with N are service replacements, identical to the factory new, just packaged and dedicated towards being customer service replacements. And then there was a third model number that I can't find. That was that indicated it was a repaired unit. So basically, what I'm getting at is, it would appear that Apple actually repairs these. The chances of somebody actually getting their hands on a repaired unit versus a customer service replacement unit are slim to none, it seems. I had 50 responses on that HomePod survey, which isn't a whole lot, but the majority of everybody, almost everybody, had factory new HomePods. A few people had service replacement HomePods, and only one person had a repaired unit. I think. I'll have to check the responses again. I can't, I'm not able to actually find that response now. I wonder if they went back and corrected their entry, and realized that they had entered something wrong, and that had thrown all my information off. But I don't think there would be much any signs of Apple having repaired them. If you look under the basket, there's clearly areas where you could design a tool to disassemble this without having any pry marks whatsoever. So, and it's also Apple. Like, I don't know. Maybe they haven't actually repaired any. And like I said, that guy that submitted the model number with a repaired unit, or for a repaired unit, as opposed to everybody else with the factory new or service replacement model numbers, maybe that guy was just bullshitting. And I haven't seen any of those in my stash. And I've got at least 20 that I have for myself personally, and none of them, they're all either factory new or service replacements. So I don't know for certain if they're repairing them, but I'm pretty sure somebody made the claim that they were. I just think that they're probably going to replace customer units with ones that have already been built and set aside for being service replacements before they go and start sending out repaired units and repairing units, as many units themselves. They've probably got enough set aside still to continue doing customer service replacements for a while. I mean, they have to. They've got a 5-year obligation at minimum in the EU, I believe. So whether that means replacing it with the exact same hardware, or whether they can also get away with just issuing you a refund for the value of the product when it fails, and they don't actually have to keep that extra stock on hand for 5 years. I don't know, but drop this woofer in here. We are nearing the end of our time together today. Alright, let's get this basket on here. And our screws in for that. Alright, let's plug this in one last time to power for our typical 3 checks. That our thing powers on, that our thing doesn't pop if it does not very loudly, and that our volume buttons are lined up and evenly illuminated. Let's get our power here and plug it in. We've got power. And we've got no
I'm having
popping.
trouble connecting to the internet. For more info.
And our volume buttons are lined up nice and evenly lit up. So we've got this one all fixed up. All right. Of course, after the stream here and after my wife wakes up, when I can be noisy again, we will thoroughly test these repairs for proper sound and seal before sending them back to the customers. But for what it appears, we've got all 3 mail-in repairs today fixed up. I hope you guys enjoyed these repairs today. If you have any questions, drop them down in the comments. If you want to get your own repaired, check out my website at nixfix.com. Shoot me an email and let me know what you need fixed. The only thing I can't fix really are the blinking volume buttons. Pretty much everything else can be fixed. Hope you guys enjoyed this one, and I'll catch you in the next one.